Okay, so for these examples, we're going to determine whether the following are a linear or a nonlinear function. And then we're going to explain why we know. Okay, so looking at this first one, you can probably automatically tell, like, nope, that is not linear. There's a curve in it. It's not just a straight line. So you could say that. No, not a straight line. But another thing that I want you guys to notice is the reason why this isn't is that it doesn't have a constant rate of change. And so what I mean by that is my change in y over my change in x. And so if you remember from last year, we learned about slope, and that was how much I rise and how much I run. So let's say I was looking at this point to this point right here on the graph. I see I go up 1 and I go to the right 1. However, when I go from this point to this point on the graph, here I'm going up 3 and I'm going to the right 1. So this change in y over change in x was 1 over 1, which equals 1. This change in y over change in x was up 3 over 1, just 3. So I see those are not the same. So that's why this one's non-linear. Where this graph, on the other hand, I see it's a straight line, and so it is going to be linear. But I also see it has a constant rate of change. So if I'm going from this point to this point, I see I go up 2 and to the right 1. When I go from this point to this point, I again go up 2 to the right 1. And so that means it's constant. It's always the same rate of change. And so I can say linear has a constant rate of change of 2 over 1, which equals 2. Because again, change in y, or difference of y over difference of x. And so I go up 2, that's my y, since I'm going up. I go right 1, which is my x. So that's for looking at graphs. Basically, it's kind of probably more simple for you just to think of it, is it a straight line? If it's a straight line, it's linear. If it's not a straight line, it's nonlinear. But now let's look at a table. And so again, it's going to be linear if it has a constant rate of change. And rate of change means my difference of y over my difference of x. And so I'm going to look and see on this table right here what my difference of y is each time and what my difference of x is. So I'm going to start with my y. Okay, well, how do I get from 36 to 30? Well, I subtract 6. 36 minus 6 gives me 30. Well, how about from 30 to 24? 30 minus 6 is 24. 24 to 18, I again subtract 6. Now I'm going to look at my change in x. To get from 3 to 6, I add 3. 6 to 9, I add 3. Then 9 to 12, add 3 again. And so I see my difference of y over my difference of x is negative 6 over 3, which is negative 2. And it's the same thing every time. And so since it's the same thing, that means that this one's linear. And that's because that's constant rate of change of negative 2. Okay, go ahead and pause the video. I want you to try number 4 and 5, and then we'll go over number 6 together. Okay, so these are the answers that you should have gotten. Number 4 was nonlinear, and that was because it does not have a constant rate of change. I see that my y's, they changed. First I subtracted 8, then I subtracted 4, and then I subtracted -2. But my x's stayed constant. I was adding 1 each time. And so when I took my difference of y over my difference of x, I see I got -8, -4, and -2. And so since these aren't the same numbers, this is going to be nonlinear. Now number 5 was a little bit tricky because I do have a straight line right here and a straight line going out that way, but this one's still going to be nonlinear, and that's because it doesn't have a constant rate of change. And the reason why it doesn't, even though it may kind of seem like it at first, so if I'm going with the one going to the right, I see I go up 1 over 1, and so this one's going to have a constant rate of change of 1 over 1, which equals 1. However, when I'm going to the left, I still go up 1, so it's a positive 1. But then I go to the left 1, which is a -1. And so that means my rate of change over here, or my slope, is going to be -1. And since these aren't the same thing, this is going to be nonlinear. Sounds a little bit tricky. Okay, now for number 6, we're going to need to be careful here. So first I'm going to do my change in y. So to get from -1 to 2, I add 3. To get from 2 to 8, I add 6. And then to get to 8 to 11, I add 3 again. And then looking at my x's, I see from 1 to 3, I add 2. 3 to 7, I add 4. And then 7 to 9, I add 2 again. And so it may be really tempting to look at this and be like, well, it's not the same numbers, so it's nonlinear. But we need to be careful. I see there's kind of a pattern right here. Both on the outside are the same, but the one in the middle is different. I need to actually take my difference of y over my difference of x and see what those come out to. And so looking at this first one, in this first column, I see I have 3 over 2. In the middle, I have 6 over 4. However, this fraction is not reduced. And so I see I can divide 2 from top and bottom. And what do I come out with? I come out with 3/2. And then my last one, again, my difference of y over my difference of x, I get 3 over 2. And so I see, even though there's different numbers here, when I took those fractions and reduced it, I came out with the same number. And so that means that this one's actually going to be linear. And that's because as a constant, I'm just going to shorten it this time, constant rate change of 3/2. So be careful for those really tricky ones. You always want to make sure you're taking those fractions to just double check and make sure that your rate of change isn't actually constant. Okay, that's it for this video. The next one we'll look at equations.